Okay, this is my forces reassessment. On her way to visit grandmother, Red Riding Hood sat down to rest and placed her 1.2 kilogram basket of goods beside her. A wolf came along, spotted the basket, and began to pull on the handle with a force of 6.4 newtons at an angle of 25 degrees with respect to the vertical. Red was not going to let go easily, so she pulled on the handle with a force of 12 newtons. If the net force on the basket is straight up, at what angle was Red Riding Hood pulling? So I drew my force body diagram, and I have the force of Red Riding Hood, the force of the wolf, and force of gravity. So I know the mass of the basket is 1.2 kilograms. The force on the basket due to the wolf is 6.4 newtons. Angle made by force of the wolf with vertical is 25 degrees. And force applied by Red Riding Hood is 12 newtons. Vertical component of force applied by wolf is F wolf cosine theta equals 6.4 newtons. Cosine 25 degrees equals 5.8 newtons. The horizontal component of force applied by the wolf is force of wolf sine theta equals 6.4 newtons sine 25 degrees, and that gave me 2.7 newtons. And since the net force on the basket is straight up, the net force along the horizontal direction is 0. So the sum of the forces in the x direction equals 0. So I have her force sine theta minus the force of the wolf sine theta equals 0. And what I did here was added the force of the wolf sine theta to both sides, and that left me with force sine theta equals force of the wolf sine theta, and sine theta, what did I do? Oh, divided by her force. So that left me with sine theta equals the force of the wolf sine theta divided by her force. So then I plugged in what I knew, and I know that she pulled 12 newtons. The wolf pulled 6.4 newton. No, 2.7 newtons in the horizontal component. And then, why is it blurry? What's going on? Okay. So then, to get theta by itself, I took the inverse sine, put it on this side, and that gave me theta equals inverse sine times 2.7 newtons divided by 12 newtons. So I calculated that, and it gave me 0.225, and then the inverse sine times 0.225 gave me 13 degrees, at which she was pulling 12 newtons. And that is my forces reassessment.